we uh, we will discuss about the application. Would you think that it is very important at this point in time for someone who not talking right now? Would you mind mute your speaker, please? Okay. Thank you very much, everyone. It is wonderful to be here and talking about the application with you all. And I I would say one thing that is very important, that if you are going to have a successful if you're gonna have a successful uh, process or the product, you have to have first is good material, which is the, of course, it have to be elanthus, and secondly, you should have a good method, which is that's what I am going to talk right now. The Let me focus on the EL at this point, because this is what my background is. So to have the, looks like Koji cannot connect. Someone may help him, please. The application method of the EL, what we can see is we can see it like there is two things that we can separate. One is using the ambient pressure, and the other one is using the vacuum or the pressure. So at first, I would like to talk about the dip and bake, and this is all for the transformer and motor. So both. It is suitable for one component, and sometimes we also see the two component as well. For example, CT, you may have a lot of experience on this, which most of the unsaturated polyester is non-catalyzed. So we will have to catalyze before putting in the system. So so it's used for both one component and two component. So it suits the repair market and the OEM, as what we always see. So most important thing is when we talk about the dip and bake, it is the atmospheric pressure. So we did not do anything on the pressurized or vacuum. Otherwise, we will call it the other. So this is the we call dipping and bake. So resin also under the ambient temperature and ambient pressure. So the other thing, I think you always see the dip and bake a lot when you go to your customer. For example, for the electric motor repair or the OEM, so you can see it a lot. So when you see the tank of this filled with resin, and then dip it, or we have something like uh, we have something like what we call the inline process, and so on and so forth. So it is very important that you can imagine and follow what I'm talking. And when this is not, this is something like uh, more like explain and workshop more. So the whenever you have the question, please do not hesitate to uh, speak it out. So as I always say, the most stupid question is the question that you have and not speak out. So just ask and then I'll answer. If I cannot answer, I will find the answer for you. So the second atmospheric pressure application would be what we call a trickle impregnation. This is the very suitable for one or two component resin. We we know it's very good, and we saw it a lot. Chop wax in Vietnam, or the uh, Makita in Thailand, and some other place that you are uh, trying to see, and so on. The Bosch in the Penang, that is also a trickle impregnation system. So I have a short video that you can see. This is the method of a trickle impregnation. Let me know if you cannot see and cannot hear it. First thing first, we will put what we call marker, and then pre-weight first. Weight before 1 inch. This slide system, and then the top to preheat. After the video, I will tell you why we have to preheat. Some of you know already why we have to. So this is the pump that pump the resin at the amount that they want. This is a trickle zone, and after the trickle zone, stop to send to the scaling and scaling point. And after that, they will cool down. They will they will take it off and then pre-measure the weight once again. So this is give you some idea on this is what we call a trickle impregnation system. This is the armature of the motor starter. Not might not familiar to you because they are using the big wires and so on, because this have to generate the high torque at the beginning. So it is the motor starter. Um, this this is something that we always see, and we have see it a lot. This is the power tools. So we trickle uh, we trickle the resin. Usually we will trickle it at the ambient temperature. Uh, Only in some very cold area that we will have elevated the temperature of the resin, because the more temperature of the resin that we elevated, the shortest of the pot life. I I say pot life, not shelf life, because most of these things will be two part, and when you put two part together, and that's a pot life will start at the point of viscosity, get up to double. So if someone can uh, remember the Dobecan 1080, 120 A and B, the viscosity, it will be around the 150 centipoise, around that. not more than that. So whenever the viscosity is get up to 280 to 300 centipoints, that's point we call the pot life. That's the time that you should not use the resin anymore at that point, because it's already start to have the free radical or cross link. So the other one that very used in a lot of stator manufacturing or the rotor manufacturing will be the dip roll. We have seen this a lot in the our example very easy is Mirari Motori. So HH 11,000. So this is very good sample of the dip roll. So it is very important for you guys to understand that. So the dip roll can be the ambient temperature or elevated or preheat the thing. This thing, the white one that you see, it is the emulsion. It's a 59 series. It's an emulsion 59 series. So this is also part of the dip roll on that. The other things, the other method that we have not seen that much in this area because of the monomer-free resin has the very high viscosity. Jinda and I went to the Solar Palau in Thailand, and they are spec in the monomer-free resin in Spain, and they want to move the production line to here. So it is the hot. When you say hot dip, it means it's hot, it's really hot. So they preheat the pot to be 160 degree and then put it in the MF resin, monomer-free resin. You cannot do this to our normal unsaturated polyester or the epoxy, because the heat in your pot will have a heat transfer to your resin, and it will shorten the shelf life a lot. But this thing will not happen in the monomer-free resin. So Solar Palau is very good example of this thing. So this is very important thing to understand. So like this, we have the hot dip and then UV. The UV thing what will help the UV is that to kill and to close the surface, and then after that we will fully kill, just like someone used the step curing. For example, we have seen the motor or the transformer processes by our epoxy, and then they want to gel it first. So they put in 120 or 30 degrees Celsius for 2-3 hours, so that it's gel first, and then after that curing at the temperature that we want. That's what the two-step curing. Very similar, technical to the UV. So you want to close the surface first. This thing can be good only for the solventless resin, because if you do the UV to the solvent resin, it will be closed the surface, and then after that when you kill, the mechanism of the cross-linking of the uh, solvent varnish is the solvent will be evaporate, and then the crosslink will happen. Think about if you surface is already closed, and and solvent try to get off, what you will see is a lot of blister and a lot of bubbles. We see a lot of this, and everyone try to say that this is our materials is not good. We have bubbles and so on. Actually, it's not same material. I can do it to have a lot of bubble, and I can do it without bubble as well. So the most important thing is the material have to be good and the processing have to be good as well. So this is come to the point of the ending of the what we call the atmospheric pressure application. Come to this point. Uh, Anyone have a question, please? Looks like no.
I have question for the MF resin because of there will be the project transfer from Solar Palau in Spain and will be transferred to Thailand should be in June because during the machine on the way from Spain to Thailand. So what is the point that we should be concerned about the MF resin process? You said that we need to heat the part first at least 160
Yes,
degree. Is it
that
correct?
is correct. Yes,
Yeah.
that is correct.
So any other points?
Uh, if you can heat the part up to 160 degrees Celsius, the 8,000 center points will come down to around less than uh, 500 center points. So at that point, impregnation will be good. So the most important thing is they have to use the material that can stand the preheat at that point. The part that built in Thailand that use the our air dry, if you heat up to 160, something will burn.
Mm.
So you have to be careful on that. So I have a full process that thing which if anyone interesting, I will share it later in my in this group. So it is very new to us. The MF MF is not new for Elantas and it's not new for Europe, but
Mm.
one use it in this area. I
Mm.
have seen the Toshiba elevator in Penang has been used it for a few years and then they stopped using because of the complication. So the most important thing is it has a very high viscosity, and
Mm.
secondly is it's is monomer free resin. You cannot just add
Mm.
uh, styrene, vinyl toluene, DAP, or some other thing in that to adjust the viscosity. The only way to adjust viscosity is at itself. So you have to replenish itself maybe 10% each month to keep the things go. So this is very very important, and I think maybe it is the second time in the region 5 to use
Mm.
to use this for the full manufacturing. So
Mm.
it is very interesting. I hope at that time the sky will open and Kang or someone who very interested in this process of using the monomer free resin will be able to come. So the most important thing is it is not about this is not about the it is not about the temperature only, but you have to make sure that your continuity will be okay, because if you keep it and then uh, test it and then leave it for 1 or 2 months, you have a problem.
Mm-hmm.
Anyone has more question about this, please speak up, because if not, I will go for the VPI or vacuum vacuum pressure impregnation system. Uh, so there's a lot of things to cover in that. And then at the end of the presentation, you can also ask the question once again. Okay, looks like no. Okay, I'll go. Vacuum pressure impregnation system or vacuum impregnation system, it is suitable for the high or low viscosity, but most important thing is the 100% solid resin, just like what we call solventless resin, unsaturated polyester without the solvent. Monomer is okay, and it is used in the both manufacturing and repair of the rotating electrical machine, high and low voltage, and then also the traction motor repair as well. As you can see, Chia and I and Faris work together with Mr. Bong in Mentech to charge the tank with the 477, and Tinda and I work along together to charge the tank with the 477 resin in the what we call I cannot remember, Daniel Lee in Rayong. So it is very important for everyone to understand the technique behind the VPI first. Then you can know that why you have to have it low viscosity, why you have to have a thixotropy, why you have to this property, blah blah blah. So it is very important. So let me start by this thing is the vacuum and pressure impregnation system. So I have a short video that also show you why and how we have to use the VPI. Of course, this is not by Elantus, and I do some research on the YouTube, and then this is very good for us. But make sure that you use it internally, because this is the maybe it's a register and patent for someone and confidential for someone. I don't know, but if it's on YouTube, I would say that it's okay to use it, but make sure that you use it in the right way. This is the short video I will show you. Yeah, so this is very, after this, I will explain you in detail, much more than this. So first thing first, first thing is when I think everyone know the VPI material, which what we have is a lot, start from 477, 478, 468, 577, 578, blah blah blah. You can talk about that. And also the some of our customer uh, also want to do the VPI for the solvent uh, material. I mean solvent varnish. It is very common in some country, but not in Thailand, because we try to explain them that the the first thing that you do when you put the vacuum on the material, you will strip off the solvent inside. So let's start with first. This is the starting of a process. The the circle part is the part, and this is two side of the tank. The left side of the tank we call is process tank, and the right side of the tank we call is storage tank. So at first, most of the resin will be on the right hand side. So at this point, I want to point out that the ambient temp of our area is different from place to place. So we always keep our 478, 477, and 468 at the temperature around 15 degrees Celsius. And this is very important to make the shelf life is longer on this, because we know that most of this material has already been catalyzed. So for example, 477, 478, and 468, especially the 468, the cooler you keep it under the cold temperature, the more the longer shelf life it would be. So at first the part will be in the normal temperature, and then after that you put the part in the process tank. This part we also have two technology. One is the preheat the part first. Two is not preheat the part. So both of that yield the different result. So due to the fact that in our area there's a lot of moistures and so on, I would fully strongly recommend to preheat the part before process the VPI. And then after that we pull the vacuum. Vacuum will help to eliminate the moisture and some other contamination and so on and so forth. And then after that you open the valve, so the material from the storage tank will come underneath and then get up to the process tank and cover the part. So, and then after that you break the vacuum. At this point the process tank is under vacuum, and then you put the positive pressures on. So the level of vacuum that we always use is 5 millimeter of mercury or 5 torr. And the positive pressure that I always use is the 90 psi. So, but all of this has been sent to you by the in this team process specification PS 43F. This is for the form wound coil. We also have a random wound coil, but the random wound coil is very easy to treat. So I'm not put in. If anyone interested, I can send it to all of you as well. Then after that, you pull the vacuum on the storage side, so ready for the material to pull back to the storage side. At this time you pre-warm the oven, and then the resin transfer back to the storage side. Resin transfer back to the storage side, and you put the lid of the storage, process tank up, and then put the part in the oven. So this is very, very systematic like this. We always do the VPI in the daytime and then put in the oven at the night time for overnight. That is what we always do. So this is the form wound coil that you can see. So I am the one who taking this photo, or this is the photo of the stator of the form wound coil, 3-meter diameter. You can see the person, the American who operate this. You see how big is him, but this VPI is 12 by 14 feet in West Virginia in the year 2000, and VPI by our 478. This is the stator for the hydropower and coal fire power generator in West Virginia. This 12 by 14 feet is belong to Epoxylite Corporation, and in the year 2001, Epoxylite Corporation has been acquired by Altana. So I was the one who installed and commissioning this equipment. It took me almost 3 months to live in West Virginia. So it's very cold area. And this is just a traction armature and also the transformer. So I also, when we say the VPI is not always also for the rotating machine. VPI is also suitable for the transformer as well. This is the ACLA in the year 2003. I was there with Abai Kunte, and this is Cotson. So we do the project together with the DuPont, and our product at that time from EPDG, Elantas PDG, the PD George at that point, the product is 468-2FXT. So we put this is the coil, and we VPI the coil. This is the VPI machine built by themselves under our recommendation. So this is the coil. After VPI, you pull it out after the process, put in the oven, and then you measure the temperature of each point, inside, outside, and middles, and so on and so forth. So this is something that Koji Okawa and JT will be very familiar with, because I'm modified it a little bit to use in the Costco. So this is the temperature. So you can see that it's part temperature is not always the same every point. So this is what you have to be careful. And when we talk about the temperature, or the duration time of the curing. Let's start from the time that the part temperature reach that temperature. So not the time in the oven. So you can see that from this point, it's almost 6 hours before the part will have 120, 130 degrees Celsius. So it took almost 5 hours. This is the Mr. Prawan and I at that point. It is the year 2004, so I still young at that point, but I'm very old now. So this is the after its assembly, and then most important thing is you need to be careful about the impregnation level, and also is that fully killed. So you took one coil out, and then out to the from the cotton to EPDG, and then you cut it, and then you scratch some part and see it by the electron microscope. You will see that some part mostly is filling the gap with our 468. So, and this is the run the DSC to make sure that it is the fully cured. So, yep. So this is end of my uh, presentation. So the next one will be the the question point. So please, anyone? Yes.
Yeah, Chin here. I just want to ask just now from a DSC, how to see it's a fully cured or not?
Okay. The the fully kill is when you see that the goal at the back. I show only one. I show only one part, but you have another part that come back and have a very not so much exotherm that they can pull it in the material. If if the curve show some uh, if the curve, this curve, there is another curve to here. If if this curve at the 60 and 50 degrees Celsius when it's run back, it's almost duplicate each other. That means there is no exotherm in and out from the material. That means the material is fully killed. There is two lines. One is heat and the other one is the cooling back. So I show only one, but if you interest, I will show the back and forth to make sure that the gap of that, if it's very less, that means the degree of kill in that point. Is it answer your question?
Yes, thanks.
Okay. Anyone else, please? So we have Koji Okawa. We have JT already in. I think the only one that we have not respond is Bear in in Korea. But yes, that's this is the open discussion time. So please. I have one request. Whoever's gonna ask, please show your face as well. I want to see you, how's you been, and so on and so forth. After lockdown for a while, so no one asks. Hey, hey, how are you? Please,
Good.
you okay, Jinda? And
Tommy, I have a
Yes,
question.
he's already in the office. You see.
okay. I heard Koji Okawa say something.
Yes. VPI tank, normally, what is the standard, level of the quantity of resin in the tank?
Okay, you asked the very good question. That means you not sleep during my presentation. So
That means he slept during last presentation.
No.
Okay. I'll try to show you as easy as I can. So there's some problem with that. Something wrong with that. Let me do this. Let me not show this. And no. Okay. The thing is when you when you are when you are going to see what's that's happened in the VPI tank, the thing is the level of the material would be around 80% of the level. We have the high level sensor and low level sensor. The high level sensor to detect not to have too much height in both process and storage tank. And the low level sensor also detect not to pass that low level sensor. Think about when you vacuum on the storage site and you open the valve, and then the resin is get to the lower than a low level allowable. You will burp the tank, and you don't want to do it because I have already did it, and I have to make a lot more installation new by myself. So it is very you don't want to do that. So 80% will be a very good number. Let me say that.
Okay. And you said high level and low level sensor.
Yeah.
That is normal. That are not normally equipped. And what is typical percentage for low level and high level? Because if it's too low, we need to replenish, of course. But yeah, what is 10% or what is
Okay.
typical?
I have the recommendation
Yes.
file that will send into this group, so you can see that for the 12 by 14 feet, how much is the recommended field. But your question is also for the low level as well. Low level, I will put it around 10% of the volume. That means if someone have flow and pass the lowest point, you will be able to catch and close the transfer valve in time before you burp the tank. Be careful when you burp the tank. It is not fun. Boom, 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 just like earthquake.
Okay.
Yeah, that will be you think about the water hammer when you open and close the valve fast, and the uh, velocity of it and viscosity of it is uncomparable to the resin when it flow back to the tank. unless it's higher in viscosity, you need to be careful. So
Okay, I got it. Thank you.
yeah. Anyone else, please?
Yes, Tommy.
Indeed.
Yeah, I understand in most of our situation here, dry vacuum impregnation is being used.
Yes.
In what circumstances wet vacuum will be used?
There is many of the theory in that, but for the process specification that we believe in extended the pressure cycle more than wet vacuum. So it means that for the P process specification from valve coil, you can see that there will be no wet vacuum at all. But if you want to have a better quality of impregnation, you will do it by extending the pressure cycle. So take a look at the process specification 43 for the Form 1 coil. You will not see the wet vacuum at all. Only someone in Europe believe in wet vacuum, but for the for the process spec in America, in the generated by the naval facility, you will not believe in the wet vacuum. So think about when the part got the heat, and then the cool resin is the flooded, the part tend to have lower in the temperature all the time. And then if you still keep the vacuum on that, or put the pressure cycle at that point, and then extend the pressure cycle, in America, we believe in extend the pressure cycle more. And if you read in some journal, you will see that the nuclear power plant or something believe in double VPI. But I can tell you, I have a very, very good fighting with officer from the I don't know who, I don't know, they are from the government specification part of the power generator came to West Virginia at the time that I was there, and he recommend the double VPI. I mean, after the VPI process, you put it back to VPI again. I told him that the only thing that you're gonna get is you're gonna get more thickness, because after you kill, you cannot get anything vacuum out of the coils and so on. Most of the void has been filled and killed and closed. What are you going to do with the double VPI? So it is not what we believe, but some of the customers still have follow the um, method of specification. So it is depend on who you talk to, and if you don't want to have a big fight, just do what they say, and then they will have a responsibility of their finished product. But for me at that point, I was young. It was in the year 2000, 20 years from now, back in the past. You can see that the Asian boy have a big fight with the American who write a standard on the double VPI. But finally, the Smith Services is doing some what we call compromising. They just do the first VPI and the second is only dipping to suit their need and so on. That's what I say is only the increase the thickness for the second VPI. When you pull the vacuum, you cannot do anything at all. So, any question, please? Any question? I saw Faris is in. You still can remember what you did, Faris? Open the microphone and open the camera. Faris? Kang. I saw Faris in, but
because of Faris use a desktop, sorry. So he may not answer your question.
Okay, that's fine. But because Faris is the one who worked with me and CT on this, so on the main tech engineering. So okay.
Tommy,
Yes.
I just want to make comment
Yes.
on the BPI system.
Yes.
I know it's very challenging and very hard to convince customer to give us a PO for the tank fill.
Yes.
Yeah, every time we get the sample, we do the lab test, and when we report to them, we said, okay, you must do the tank fill, your viscosity is high, and film build is low. So the most challenging part, like recent case, the ABB, they can't even have a budget for tank fill. So, I mean, is there any recommendation that we can convince a customer other than our report?
It is very difficult to answer that question and make everyone happy because the sample is coming with a very high viscosity, and you know that to impregnate the coil for the lower and mid voltage, you need a very good viscosity to impregnate in the slot and coil that's wrapped by the mica tape and so on and so forth. So the more viscosity, the less impregnation that you're gonna get. If you talk about only viscosity, the things that can help you is the diluent. But after you put the diluent more onto the system, just like 477, 478, you can test in our laboratory that the physical strength and electrical strength is reduced. For the rule of thumb, the 5% of the diluent that we add into the system, the 10% of the electrical and the physical property will be lower. So if you and depend on the design of that coil have a good margin of errors or not. If they are very sure that the design of their coil have a good margin of error, you can do that. But CT, you have to let me go out and fry the char kway teow first before you do that. Because if I'm still here, I will not put our company in that. That is very risky to recommend those kind of things. Even we know that sometimes it will work, so it will be very risky. So I think face the reality is one thing, and then if they got the contract which I know I talked to Mr. Bong 2 days ago. He has already lost the contract, so we will not get the order from Maintech Engineering. So the contract will be to SWTS or ABB. He said he lose to the other. That means the ABB and SWTS. So face the reality is better here at this point, because I will not recommend us to do it in the way that we believe that it is not the right technical recommendation. Is that answer your question?
Yes, Tommy.
Okay.
You know, most of the time for this kind of situation, the cost is always a concern. The cost is always a concern. So,
Haircut
so
by
for
my
example,
wife. Don't look
if,
at this.
yeah, if a customer has only one contract to impregnate one stator or one rotor, so I think when they calculate, it's not worth it to have a tank fill and do the impregnation.
Sometimes you can recommend them to use the insert and then use the resin as much as it require. So maybe for drum or something for that contract, and then after that you put it back in the system. That will be okay. So let me know what kind of size of the stator or rotor that they want to process, so we can design the cylindrical insert for them. It is very easy. You have to appreciate that in the past, before Altana acquired Epoxy Light, we have both resin and equipment, so the knowledge of equipment still with me. So it is very I can close my eye and I can, if they have let us know what kind of size of the part that they want to do the impregnation, we can recommend the insert for them.
Yeah, I just want to share this technology in the market. They can make like a epoxy very stable for the viscosity for 2 years. I think Kang is working on this, but we did not make any progress. Maybe Kang can discuss with the own, see if we still can do something. At least we can improve. Whether we understand that our competitor can offer the product. Within 2 years, the viscosity only changed about 5%. So we may need to review to see if we can do something.
You may at the room temperature.
Yeah, it's in the oven. They have some technology. They can, the viscosity will not go up within 2 years. If I'm right, so like 5% only difference.
There is the technology that we can do. That is the hybrid between epoxy and polyester imide. That's whenever you have a heat, you can dissipate it out and not correct it in the molecule of that. That is one of the things that we always do. I can talk to Kang. We did discuss about this even in the time of before we have been acquired by the Altana at that point. So we start the project, but the project did not go anywhere. So anyone have a question, please? So if no one have a question, I would like to emphasize once again that only the good material and the correct process technique and good storage condition can give you the right solution. So that's I think that is I'll end my presentation at this point. Anyone have a question? Some more? Peng Lee. Peng Lee, I saw you are going to say something. No. Because you're gonna say something, Peng Lee?
No, nothing.
Let me see your face.
Tommy,
Yes.
right now, are we working with any vacuum impregnation manufacturers to promote to customers or no? After acquired epoxy light, that's all. No, we don't work with any.
No, we know them, but we did not work with them. We know them. For example, the one who installed the full line for the GE in Haiphong, we know them. Yes, Hittech. We know them very, very well. So Hittech, yeah, Peter Kane, and now the managing directors already changed. So no, we know, but we did not work with them. This is one of the things that we can still discuss with them all the time. The other processing equipment, but not involved in our resin, is the coil winding machine, the toroid winding machine. I know Joel very well, and in the past we exchanged information, and everywhere that they go to, it will have a potentially be your customer as well. So it is very, very, very good to have the collaboration with equipment making, just like what you do with the German oven last time. You remember that? Hedrick, right, Hedrick.
No, now what I understand now in Asia, most of the newly installed vacuum impregnation or vacuum casting machine are coming from China. So I don't see any manufacturer coming from Europe or US. So any chance that we will work with the China equipment manufacturer?
Yes. Last time I still have the information of someone who offered the system to Daniel Lee, which I opened the video call between him and Steven once, and then we still exchange some information, but not fully work focusedly on that. No, but yes, I have a lot of this information that I can share with you on this. So this is one of the ways that we can promote our product by working together with them. That's one of the way. Thanks for bringing it up, Chia.
Thank you, Tommy. If you have the list, please share with us.
No problem. Anyone else, please? If not, thank you very much. And next time in the team meeting or conference, I will be on the beach.
Okay, but just wear something.
Okay. Sure. I will wear something. Okay. Okay.
Okay,
Make sure
thank
that
you.
I wear something. Okay. Okay. Okay.
You are recorded all the time.
Yes, yes. I will upload this to the YouTube. I will send you this presentation. I'll upload this to YouTube so you can come back and review it all the time. So okay.
Tommy,
Yes, sir.
maybe your file is very big, so you share in the M drive, and then I will put in the one folder, then let you know.
No problem, sir. No problem. And video file that we talking and we discussing has been recorded, and I will put it on the YouTube. So just get the link, and then you can review it anytime, anywhere you want. Okay. I will have to go back to the New York City to meet up with Alicia Key. So thank you,
Good luck.
everyone.
Thank you. Bye.
Thank you, Tommy.
Okay,
Thank you.
bye.
Good luck.
Thank you.
Bye.
Thank you.
Bye.
Thank you.
Thank you.
See you next week.
Yeah.
Thank you.
Thank you.
Thank you very much, Tommy.